Hi, my name is Taja Hawkins and I'm working on Lab 2, Problem 1. So Problem 1 has 5 to 6 parts. So in part 1 of question 1, it asks us to solve 2x minus cosine x is equal to 0 up to 5 decimal places. So what I did was I used I assigned like the number of points to be up to um 1 million because that's going to help you get to 5 decimal places. And then I use a linspace to define the range of x, and I set the n or the iterations to be up to the number of points. And then I also defined what y is. Y is gonna equal 0, which equals this equation up here. And then after that, I just scattered the plot. I did adjust the mark size, and I scattered the plot based on what the graph displayed, which was at y is equal to 0, x was about 0.450185, to kind of like show where the y is equal to 0, like where it approximately is at x. So when the graph displayed x was about at 0.45019, and I was able to figure this out using like the zoom function in Matlab. So then for part 2, I pretty much did the same thing. The main difference was the number of points. Instead of being 1 million, it's now 1,000, because instead of 5 decimal places, we're wanting 4 decimal places. And then the answer, when I got the graph, it was at 0.7549. Problem number 3 is also the same. Well, going back to problem number 2, it asks to solve x to the 5th plus x plus 1. So what also changed was that I set y equal to this initial side of the equation, because y will eventually equal 0. So for part 3, is asking us to solve x squared plus x plus 1 is equal to 0 up to 3 decimal places. So again, with the number of points, I changed that to be 10,000. And then I set y equal to the left side of the equation. And when the graph displayed, using the zoom function, for this graph, x wasn't necessarily at specifically 0 when you zoomed into the thousands place, but estimately x was at y is equal to 0, x was about 0.33. But that's very like an approximate approximation. Same with part 4, it asks for us to solve x squared plus the exponent of x is equal to 0. So it asks for 4 decimal places. So sorry, it was actually a hundredths place, or 100, like the number of points is going to be 100,000, because it's asking for x up to 4 decimal places. So with this problem, we changed the y to be equal to this left side of the equation, scattered the plot, and we saw that at y, x was about 0.3305. And then for part 5, so for this function, we define the array function, and I used this right here. And then we use like the f0 function to kind of guesstimate like where the first zero of like the function would be, and I guessed -2. Then after that we were able to like display the first result, and then we were able to find like other zeros by finding like closer guesses. So like -2 wasn't like specifically have like x is equal to 0, so I tried -5 and -8. And when I did that, the results were, if you notice over here, the first, second, and third zero using the area function, it was at about -2.33811. The second one was at -5.52056, and then the third one was at -7.94413. And then the last problem asks about finding pi up to 5 decimal places. So we first initialize the variables. So this is like kind of like what I define the variables as. And then we use a loop function to calculate the series. And then I multiplied the sum by 4 to get pi. And then I just use like a fprintf to display like the result of like the approximation of pi. And when we run the command, pi is approximated to 5 decimal places, is going to be 3.14159. Thank you very much.